Hey, I'm back. Modifying wall sweep returns. Now, instead of prefacing the chapter and then getting interrupted by a BIM manager note, I'm going to read the BIM manager note first. Although profile families from RFA files can be used in wall sweep type properties, a wall sweep is a system family that exists only in a REVIT project. New sweep types can be created only by using the Transfer Project Standards tool or by duplicating existing types within your active project. Keep in mind that once wall sweeps are added to your project, they can be scheduled like any other project component. And that's good, but you may find, and you're going to find, that with these additive and subtractive templates, you may have to bring some of these designs forward by transferring project standards, but I don't have another project open, but we recall doing this. Cherry picking what it is you need to bring forward. Because in these, when we create these sweeps within a project environment, and we are in the edit assembly dialog box, these sweeps that we create are loaded profiles into the project. And then we add them and change their construction parameters accordingly. And then they exist within this project. But as is the same case with wall systems, they're not loadable RFAs. Sure, the profiles are loadable RFAs, but the sweeps themselves are not. They become synonymous with an in-place system, like walls. We can transfer them, we can create them from existing types or copy and paste them from other projects. And the same holds true with the sweeps. So let's just cancel that for a second, cancel this. And remember that in the previous exercises, we learned how to include sweeps and reveals in the assembly of a wall type. However, you can also apply a sweep to a wall if it is needed only in a limited location. For example, you might need to create a chair rail molding in one special room. To accomplish this, go to the Architectural tab in the ribbon and click Wall, and then Wall Sweep. You can place a sweep on a wall vertically or horizontally by changing the placement option in the ribbon while this Wall Sweep tool is active. Select a wall sweep type from the Properties palette and pick the wall faces to which you would like to apply the sweep. If necessary, the sweep can be adjusted vertically in elevation or section view. And that's fantastic because there's just so many tools that we have at our fingertips. So yeah, architecturally tabbed to the wall tool, notice this wall and a reveal. We know what it does, and you can see as you hover over a wall surface, you're able to place a vertical or horizontal sweep, and we'll be able to change whatever profile it is that you want and create other types as you go along. So just cancel that there for a second, and let's put it in the horizontal. Get it over here. I'm going to get it really low for a second. Really low. And I'm going to put one over here. I'm just going to hit modify or escape to get out of there. Notice that it did indeed might have cut around the corner and swept around the corner. Now, we can look at it and see, whoa, oh, there it is. It's at 2 feet off the ground. It's 2 feet off the ground. Now, if we go into the plan view, I just want you to notice that we don't see it. Or do we? Well, there's the casing. We can see it. But now, just deviate from center a little bit. What if I put it at 4 feet? Tab. And I hit apply. It's gone. That's a quiz. Why? Now we're going to move on from there until it gets to the end. And we're going to reveal the answer. If you want to try to follow along, you're more than welcome to multitask on that. It's at 2 feet. You can see it. Now it's at 4 feet. I can't see it. But I can see it in 3D view. And I can see it in the east elevation. And I can see it in the west elevation. If I zoom out, I can see that. All right, so in addition to that, what we've going to continue on is the fact that we're able to manipulate this molding. In this particular aspect, if we were to click on the sweep, shouldn't call it molding, modify the return, or better yet, we could click on the sweep and remove a wall. If I was to move out a little bit, you see remove this wall from the sweep. Well, then it's gone. And now what? Well, we could take a look at the end of this and we can modify the return. Say, okay, well, you know what? Let's just keep this the way it's supposed to be. by default, and click the edge and see that we're perfectly 90 butted out a little bit from the surface of the return wall. And if we hover around, you'll see this knife appears, and we start to trim up the molding to our liking. Return and straight cut return options. You could select a surface on the edge of the molding, and you'll see how you can cut it, and you could do some manipulation of that. Now, I'm going to hold it there for a second because there's a little more to this than that. It's not as straightforward as it may appear. Now, which way is up and which way is 90, right? You have to understand your right-hand rule. So let's just think about this for a second. We have, we maybe need to extend this molding to a special place. Well, what if we were to draw another wall architecturally, drag it over this way. And from last exercises, we remember that we can match properties. We can go to modify, and we go to match property, select the wall type we want, and then match the wall type to receive the same wall type. And notice that we have the same consistent wall type now, abutting out from this apex of this wall system. Now, what is that apex? Well, we could take the core, take a look, and see that it's 45 degrees from its longest leg of its triangle. Its hypotenuse is 45 degrees. Again, remembering our triangles, we're gonna need to remember our triangles. Triangles are important, right? We're triangulating coordinates, and even these surfaces. Every surface has a triangulation surface pattern where we're reflecting light. So just remember, there are many triangles that you have to keep. Just remain cognizant of. This is there's a lot of geometry, trigonometry, calculus, algebra plays into this. You don't have to be a mathematical wizard, but you have to know your numbers to a certain extent. Now, yes, it's just 45 degrees. Well, if we create a wall sweep, we know that the tool should, we can't do it in the plan view, we can do it in the 3D view. We know that the tool will give us that sweep along that angle. And sure enough, you'll see it'll follow the share rail that we put in prior. And you'll notice it actually can, the length can be ascertained and scheduled. That would be a very good, estimating millwork cost could be a challenge. However, REVIT makes that task expedited exponentially, but we still can't see it in plan. Now, what if we didn't have the wall for all intents and purposes? The molding's gone. Well, what if we know it's going to be there soon? Would we have the nerve to modify the return with the negative 15 degree angle? Would we have the nerve? Now, take a look at this. Well, the east elevation, let's zoom out and take a look at our model here for a second. Let's take a look at some more elevations here. Well, here's the north elevation. And if you can see the view cube, south, north, east, west. So let's just spin this around so you could get an idea of what I'm looking at in the north elevation. Where now north is here, south is here. And looking in the north elevation, we're looking this way. And sure enough, well, there's that molding at a 15 degree. And what do you know? That's it right there, butting out from the orthographic view. Now, again, for you AutoCAD users, you AutoCAD LT users, if you're stuck in that office and that's what the boss wants to purchase, and that's your subscription, if that's your comfort zone, fine. But just know it, that you know how difficult the orthographic projection can be in a frantic, hectic design process, dynamic and fluid design process. You remember? Well, keep yourself focused. This can help you. This tool can help you. Now, knowing that, you could do it and cut it yourself without having the computer do that extra step for you, do the math for you. So, where does that lead us? Well, that leads us, Howie, to modify these sweeps. Because we created a sample chair rail sweep on the interior face of the walls in this model, and we looked around. If you also select these sweeps, these profiles, if they're not joined, you can actually drag them. You can drag them from edge to edge to extend them. Now, if you look, I'm looking at the east. Well, here's west. Here's east. I'm looking east. I'm dragging this interior casework from the edge out. I could flip it upside down if I want as well. If you notice where it sweeps as I drag it, not in elevation, doesn't affect anything other than that. Now, offset from level, 6 foot. I can't see it over here. I still can't see it. And again, that quiz is coming at the end, right? Well, as we go and trim these this molding with the modify return tool, got to be in the right viewport. Select a modify return. As we use this little knife, it turns into a little knife. We're going to be whittling, and you can see the only surface you can choose from is right here. And well, there it is. If I do a straight cut back, come back, do the angle, back and forth, right? You could actually, oops, it's already done that way. Start your little miter box right here. But you could do it. You could do it in other views. You could select this molding in an elevation view and do the same thing. You could still select the edge and do it in elevation. Now I can't see it. It's still there. See how it's butted? It's coincident now with the exterior wall. It hasn't made the turn. So again, the bidirectional associativity of this software is what I'm trying to stress, but we still can't see it in plain view. Now I'm going to cut this one a little short, and I think that I've illustrated my point as how you're able to manipulate these returns around these walls. Now, as we do that, again, it's beneficial to be able to see in multiple views at the same time, 3 dimensions, 4 dimensions, and that's the power of the software. So again, we can't see it in this view. So we have to go back to what we discussed earlier and really challenge our memory banks and remember that this is a camera and every single view has certain depth to it. Color palettes. So in the view, and sometimes this can get tricky, we have to remember that there's a view range, and there's a view range in a template. But every view has a view range. Now remember we discussed from an elevation perspective, depth clipping. Well, there's depth clipping in a plan view as well. There's many variations of clipping, displaying things by elevation. We recall looking at this dialog box where we have the overall range of 7 within the zone we're working. And the primary range top, number 1, is the primary range top, number 1. It's level 1 that we're on, and it's set at an elevation of 7'6". And we have to remember that the primary range plane is set at 2. Is number 2, and it's set at 4 feet. Cut plane, associated level 1, 4 feet, but it could be absolutely from level 30 at 504 feet, or relative to level 1 at 4 feet. Remember that. We'll get into tagging later. Now, my cigarette went out. The view, the third key is the bottom, the primary range of the bottom. As you can see in the primary range dialog box to the right, that is at associated level 0, which is usually synonymous with the level you're on. So if if you're on level 3 and it's 50 feet in the air, 30 feet in the air, well, it'll be synonymous with that, but it'll be 0 at relatively to 30 feet, or absolutely 30 feet. Now, let's not get caught up in that, because REVIT addresses that, and it solves that disconnect that AutoCAD has unfortunately succumbed to from a platform perspective. Now, don't get me wrong, Project Navigator addresses it, and you can adjust your constructs accordingly. Now, however, there's a lot to be said for expeditious software coding. And then the primary range, 5, as you can see, is everything above the lower cut plane to the top plane, to include the first, second, and third key, the top cut plane and the bottom. And then the view depth, number 4, is the depth below the lower cut plane, bottom cut plane, and 6 is that view depth. And 7 is the overall range of the view. And it just so happens that we don't know. Well, we do know, because it's 7'6" to 0. So the overall range is 0 to 7'6". If we put in an offset on the view depth, that would increase. If we raised the bottom level, it would decrease. If we lower the top, it would decrease. If we adjusted the cut plane, it wouldn't change. It wouldn't change in view range, because that exists within the range. A slide. So it's at 4 feet. Well, okay, we know that now. Let's take a look at this this molding. So look at both of them. We can see the inside from the north, and we can see the outside from the north, which is good in this view. So let's go to annotation for a second, and let's take a look at dimensioning this a little bit. Now, the first thing we should dimension is the molding itself. It's 7 1/4. Well, if I was to draw in a detail line from here up 4 feet, not on an angle, silly. If I was to just draw a detail line just from this first floor reference line, level 1, I was to hold it orthographically at a 90-degree angle and type in 4 and hit enter. Well, I would see that 4 feet is right here. Now I could edit this line, override graphics of this detail line by style real quick. Solid, red, okay, line weight 6, pattern dot, apply, okay. And you can see, well, there is 4 foot. There's 4, and it just so happens to be that it's below, right below the molding, the exterior molding. And you don't see it in plan. Well, we said this was 7 foot, 7 1/4 of an inch. Well, if I was to take another detail line And I was to find the midpoint of this particular casing and draw it out here. And if I was just to match the properties of that, if I can, hopefully I don't know if I can do it with detail lines. No, I can't. I'll have to change it by, well, I'm not even going to change it to the line weight yet. I'll just leave it like that. I could create a filter, but let's just leave it like that. So we know that this is the center, midpoint of this molding. And we would annotate it again with a line dimension, click it, click the top. We could see that it's 2 7/8, and then 2. I'm sorry, 3 5/8 and 3 5/8. This one's, I took it to the wrong line. It's 3 5/8 from the center to the top, and 3 5/8 from the center to the bottom, or for an overall distance of 7 1/4 of an inch. Now, knowing that, why don't we just add in the other dimension while we're here? Bring it over here so we can see that the bottom is 4 feet. Now, this family, when we inserted it, if you remember, this sweep, if you remember when we placed it, when we placed this sweep, you notice that wherever our arrow picked would be the center of the casement. So that would be the grip. If the casement was, that's the casement, we were holding it like this, moving it around from its center, or its midpoint. Now, if I was to look at this, look at its properties, offset from level 6 feet. Well, I don't see it. Now, what if I was to offset this from level to 3 feet? Hit apply. This is the interior molding. I put it below the cut plane, and you could see it now in plan. We could see it in plan. Oops, you could select it and see it. Now, if I moved it up to 4 feet, I can't see it in plan because it exists right above the cut line, and the middle of the molding, or casing, is 3 5/8 above it. So, if I was to look at this molding again, and say, well, what if I put it at 4 foot 3 5/8? What if I offsetted this from level 4 foot 1? Well, that wouldn't help. 3 foot 11 and 30 seconds. What if I put it at 3 foot 11 and 30 seconds? A 30-second below 4 foot. Well, you'll see it. You'll see it. It crossed the threshold. It crossed the threshold. But now, I only bring that up because that is an important aspect in visibility graphics, in any architectural platform. It's just below, right? I brought it down just a little bit, just so that it would get cut by the cut plane. Now again, if I was to look out here, grab this, oops, hold on, grab this. Now, if you notice, this one you can see, because it crosses the threshold. But again, the one on the exterior, we still can't see because it doesn't. Now, what if I brought this one down? If this one is the same width, and we discussed that, it's 7 1/4 of an inch. What if I brought this one down, and excuse me, if I was to say, okay, well, for any of you bipolar folks out there, what's 4 foot minus 7 1/4 of an inch? Well, that would be 48 minus 7. 47.75. Oops, not that one. This one. And sometimes I do the math, guess 47.75, and then I adjust it. Well, now, as you can see, it came down. You can see it within the cut plane. I brought it down just a little bit, the bottom below the cut plane. Now, I could have easily changed this down to 4 and brought the top of it down below the cut plane. And that, being that it exists under the cut plane, you'll see. Now, this is where we could change its projection. Being that it's below, it's projected below the cut plane. This is where you can represent it in a different graphical representation through its visibility graphics, remember? If we look back at the visibility graphics for the view, I know I'm going off on a tangent here, but this is important. The book, it breezes away from this. If you look at casework, projection, if you look at casework, right? How it looks in projection, how it looks when it's cut are two different things. So that's where we can get into what if we wanted to represent the molding in a different line type or a different line pattern to make it more aesthetically pleasing. So I'm not going to go off on a tangent with that. But again, you need to know that now, not later. Excuse me. If I haven't already drilled that home to you, then I haven't done my job. But again, we can't just assume something. Now, you could be spending parts of your days finding solutions like this to get it to display graphically by the AIA standards. And this tool will get you there, and it'll get you far and far beyond that. So, I'm going to read it again. Failure is almost as unpleasant as quitting. And sometimes it takes years before a quitter tries again. Failing is like getting an F on your report card. Every time you fail and quit, you rack up another F. You know what happens to kids who get lots of Fs? After a while, they stop trying. Adults are the same way. Entering a room. Smoking is like entering a room with a door that shuts behind you. If you stay out of the room, you're okay. Once you enter, you can feel hopelessly trapped. Now, yeah, addiction plays into this. But sicknesses of the mind, you know, I'm all about empowering. Architecture is the study of space, time. Now, anyone who knows anything about computers knows that you should always interleave the right characters in your code.